So before we get started, I will explain the lab for those of you that are joining from YouTube or other platform. Today, I'm going to start with the bottom section right here. So the objective of the lab is to basically have configure VLANs in this switch. I will explain in a little bit what the VLAN is. Each of those pieces will have access to one VLAN. We're going to have the VLAN routing inside the switch. And then this Fortigate device, that is a firewall, will be used as the next hub. So this switch will be a layer 3 switch, and this Fortigate device will be used as a layer 3 device, right? And then we're going to stop here from this portion of the lab. Why do we, what is the objective of this lab? Is to basically understand the concept of VLAN and to be able to do some inter-VLAN routing from the layer 3 switch, which is different from what we call inter-VLAN routing, from what we call the router on the stick, right? So let's introduce the VLAN routing from the layer 3 switch first, and next time we're going to do the router on the stick. So what is a VLAN? VLAN. A VLAN is what we call virtual LAN, right? So we have that topology: internet, firewall, switch, and endpoints. PC1, PC2, right? And this is our switch, and this is firewall. So this is the typical network topology that you're going to see in enterprise network. This one is very small, and it will scale from there. Scaling meaning that is going to increase in number, in size, without reducing the performance, right? This is scalability of a network, one of the characteristics of a good network. So we learned that in the world of networking, this device will be called the edge device. This side will be called LAN, and this side will be called WAN, meaning the world of the internet. So LAN is basically the internal network, or maybe just a network that is one switch and multiple devices will build a LAN, right? So understanding what the LAN is, what is a virtual LAN? The VLAN gives you the ability to do what? If you have one switch like this, it gives you the ability to do some network segmentation. Then you're going to have VLAN 1. And each of those VLAN will be what we call a broadcast domain on its own. And it becomes very interesting because meaning that if I have 3 ports right here, for example, 3 PCs are connected to the broadcast domain, what will happen in a single broadcast domain? What will happen is that if the traffic goes from this port, it's going to be broadcast in every single port in the same what? Broadcast domain. So if I ask you what is a VLAN, you're going to say a VLAN is a single broadcast domain. This is the definition of a VLAN. Because within a VLAN, we're going to have a broadcast domain. Meaning, if I have 2 other computers connected to this, I have this computer right here, and I have this other computer right here. Those 2 will also be in another broadcast domain, meaning if the traffic goes there, it's going to come out only right here. You see the color are different. The red will never go to the amber, right? Because this is another broadcast domain right here. So let's use another color for another couple other pieces that are connected right here. So there, those 3 pieces also form another broadcast domain, meaning the traffic will come in from here and it will go out through those 2. So how many broadcast domain that we have here? We have 1, 2, 3, and 4. 4 broadcast domain meaning 4 VLANs, right? And one thing that you need to know about VLAN is that VLAN operates at layer 2 of the OSI model. And the type of traffic that goes at that works at layer 2 is called what? Frame. Very important. And what we know at layer 2 is what? MAC address. And what we see on those frames is the source and destination MAC address, meaning what type of device is being used, is transporting, is sending the frames, right? So that device will have a burn-in address that is called MAC address. This is layer 2. So it's very, 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 very important. So another thing that you need to understand within the same broadcast domain, there is no communication at layer 2 between 2 broadcast domain, meaning broadcast domain 1 cannot talk to broadcast domain 2, right? It will not happen. No communication between broadcast domain. What else? So in order, like, as the network admin, I might want my PCs in broadcast domain 1 or VLAN 1. Let's say PC 1. I want PC 1 to communicate with PC 5. Then I will need more than just the MAC address. I will need what? An IP address, right? So I will need the IP address for VLAN broadcast domain 1 for this PC 1. And I will also need the IP address for PC 5. Having those 2 IP addresses, then the device can only communicate within different broadcast domain with IP addresses. Meaning there will be a need for a layer 3 device, right? There will be a need for layer 3 device. So for device to go from VLAN 1 to VLAN 2, we need to send that traffic first to a L3 device, right? Meaning for every VLAN, there is what we call, there is a subnet. What is a subnet? For every VLAN, there is a subnet. Now, the subnet is what we call a range of IP address. For example, 192.168.1.0/24. That's a subnet. So VLAN 1 will have a subnet like this, for example, a range of IP address. We already talked about what this subnet means. VLAN 2 will have a range of IP address 192.168.2.0/24. Now, on /24 subnet, the 3 first octets supposed to be the same for the device to communicate together. If they have to be on the same network, right, for them to be able to communicate. So if it was only VLAN 1 and both of those devices will match, it means the subnet will match. It means they are in the same VLAN. For every VLAN, there is a subnet attached to it. Every VLAN at layer 2, L2, there is a subnet at layer 3. That's the interaction between layer 2 and layer 3, right? Adjacent layer interaction. That's it right there. For every, I will repeat, for every VLAN, there is a matching subnet. Now, like people said that there is an argument that says there is a different, there could be 2 subnets for one VLAN. I haven't seen it in production yet, but that's an argument that people are making. But for what you need to understand, for every VLAN, for every broadcast domain at layer 2, there is a matching subnet at layer 3. Meaning, so if we have 2 subnets that match, it means they are in the same VLAN, right? That's, if I see 2 matching subnets, it is the same VLAN. For example, I have one switch right here. There is a connection between the 2 switches. right? And then I look at the subnet, the routing table on this switch, and I see this is the routing table, and I see a subnet 192.168.1.0/24. And I also see in this routing table a subnet 192.168.1.0/24. Guess what? When I will look into my VLAN, this subnet and this subnet will be the same VLAN. VLAN 10. And by the way, this is called a trunk. I will introduce trunk the next time, right? Or I can even talk about trunk today. So if you understand what a VLAN is, you will understand what a trunk is. By the way, those are my switches. In this switch, I have a broadcast domain right here. In this other switch, I have a broadcast domain. In this switch, I see this subnet and I see this subnet. That those two subnets can only be for one VLAN, because for every subnet there is only one VLAN attached to it, right? So if I see another subnet 192.168.2.0/24, it means there is another VLAN. And we'll say another VLAN, say what? Say another podcast domain, right? And say another subnet. All right. So what is the VLAN used for? VLAN is used for segmentation. For example, I have 10 devices that are connected. That's a switch, right? Those are my switch port. And then I have devices that are connected to it, right? Now, this is PC and PC and PC. And this is printer and printer and printer. This is IoT and IoT. What is IoT? Internet of Things, right? It's everything that can be on the internet, like TV, fridge, what else? Like you name it, the doors, electronic doors and stuff like that. And this is maybe servers. I will have it as servers. Just look at this. For every of those, I will have a separate color. Servers will be yellow, right? So we can materialize it. So the servers are yellow. The IoT will be what color? Blue. I don't usually like to use red because red is like the network is down. IoT. Now the PCs will have which color? Green. PCs, all the PCs will be green. All right. PCs. Where? So, and another, the printers. I will have yellow. No, I already have yellow. I will have amber. Amber for the printers. Printers. I have amber color on the switchboard. And now the last but not the least is the blue for those ports. Okay, very, very, very important. Look at this. Now, why do we segment? We want to segment because I don't want my PC traffic to be mixed up with the printer traffic, or my PC traffic to be mixed up with the server traffic, or my PC traffic to be mixed up with the IoT traffic. Why? Because there is something in network that we call quality of service, QoS, for example. So the quality of service is basically to set the priorities between the traffic. I can say this is the order of my priority. It's PC first, then is printers, then is server traffic, then is IOT, right? And then is what? That's it. So I will give a higher priority to my PCs, then a lower to my printer, then a lower to the servers, then a lower, because the traffic that is important to me is this, the data traffic, right? And I set a QoT. So there is a need to separate that traffic. Is called what? Segmentation. Network segmentation. So, and then when we finish separating it, then we can use a firewall to basically do the access control, right? Start deciding who is going to talk to what. Now, the PC can talk to printers because they want to print, but printers cannot talk back to the PC, right? And maybe IoT cannot print. So you can decide, you can start setting some access control. And the reason why you'll be able to do that access control is because you already have that level of segmentation at layer 2. So the VLAN is very important. It's a security feature too, right? It gives you the ability to start doing segmenting your network at layer 2, right? This is where the segmentation starts. So if you look at the colors, you're going to realize that here we have how many broadcast domain? Because only devices from the same kind can talk to each other, right? Let me get now we're going to talk the green PC. This guy right here can only talk to this guy and talk to this guy. So, and it's going to be in the green broadcast domain, right? Devices in the green broadcast domain can talk together. They're going to be right here in the green broadcast domain. So this is already what I would call what? VLAN green, right? Can we call VLAN green? So, and same thing for printers. The printer is going to be in what's the color for amber. So this is the printers, VLAN amber, and then we have the IoT that is blue, and then we have the servers yellow, right? So only devices in the same color can communicate among themselves. Meaning, if I send a broadcast right here, the server is only going to talk to this guy and this guy. Why? Because they are in the same broadcast domain. This is how the switch works. And all those things can be configured. This is what I will be doing today. I'm going to say this guy is a PC, and then he is connected to the broadcast domain yellow. Or now, instead of using colors, I will be using names. I will be using number, right? Number and names. I will say PC1 is connected to port 1, and the port 1 belongs to what? To VLAN 10, right? Name. Now I give it the name. Name, I will call it maybe green. You see how we do the segmentation. And then I will say this IoT 1 belongs to port 2, and I will say port 2 belongs to VLAN 20, VLAN 20, and VLAN 2 is called blue. Obviously, in production, we're going to have different type of names, right? But this is the same process that we're going to use. And then I will say this port right here is this device is called server 1, is connected to port 3, and port 3 belongs to VLAN 30 that I will call yellow. So today, in my naming convention, I will be using those yellow and blue and green. But next week exercise, I will start using production name. So you start saying, getting the feeling how things work. Let's say we have quite a large building, or maybe different floors. Now I have this switch right here that is basically controlling all the LAN device of floor 1. And on that switch port, I have devices that are connected. And in another floor, I have another switch, right? And that switch have switch ports. And on that switch port, I have devices connected to it. So here I have PC, I have PC, PC, for example. And they have, let me have the colors. All my PCs are yellow, and yellow. All right. And I have my printers. This is printer, and another printer right here. So I will have the printers in green. This is exactly how the production works. If you don't understand this right now, you're going to have a big problem. So PC, okay. Now, what do we have also in production environment? We're going to have PCs and printers and what else? Cameras, right? The cameras also want to be on the network. They're going to connect to the switch. Oops. So I will have C for cameras, C, and C, right? So those are all cameras, and I will have the cameras in purple. Cameras. And okay, the last two maybe is like vacant switch port. Anyway, so for us to be able to communicate within the same broadcast domain, this connection needs to be able to understand that when the traffic coming from the yellow, it can talk to the yellow connections. When it comes to purple, it can only talk to purple down there. When it comes to green, it can talk to green, right? So this cannot be a regular cable. That's why we call this cable trunk. What is the trunk? No, there is no C. What is the trunk? The trunk is that link between two switches that is tagging VLAN traffic. Right? Keyword, tag. That's why sometimes we call this port a trunk port or what? A tag port. Right? Because how is it able to tag? When the VLAN, when this PC, where is, when this PC try to communicate to sending the communication right here, he wants to communicate PC1 wants to talk to PC10. So when the traffic gets here, this trunk will look at the traffic and then they will know it's coming from VLAN 10 traffic. So it's going to tag this traffic with this, like it's going to tag the traffic right here. At this port, the traffic is being tagged. So when it travels the network, when it gets here, this port going to look at it and say, okay, I see this tag, right? This is the tag right here. And they're going to see the same tag right here. And then it's going to be like, okay, this tag is for VLAN yellow. It means it can talk to every PC from VLAN yellow, right? What's the name of this tag? The tag is called IEEE. It's a standard, network standard. IEEE 802.1Q. If you didn't get nothing from this course, from this class today, remember this. IEEE 802.1Q. Now, if you take this and put it on ChatGPT, and then you say, elaborate, teach me everything about IEEE 802.1Q. It's going to tell you everything about what I told you today because it's the layer 2 standard, right? It's the data link standard, including VLAN and trunking. So who say VLAN say trunk? Who say trunk say VLAN? Because the trunk is tagging the VLAN traffic from one switch to another, right? So if it's the traffic coming from PCC, it's coming from there. When it gets to the trunk will tag it with this. Okay, I see this traffic is coming from VLAN purple. It's tagging it, so it's going to go over the trunk. And when it gets here, this port will see that tag and then say, okay, this tag belongs to VLAN purple. And then it's going to forward it to all the ports in VLAN purple. All right? In case we don't know where it's going. If we know where it's going, it's not broadcasting anymore. This is a topic for another day. But now we don't know where the traffic is going. We're going to broadcast to all the ports. Why? That's what the trunk does. The difference between a trunk port and an access port, this is the next thing I wanted to say. Every port in the switch, a switch port access interview question or trunk. Every switch port can either be access or trunk. What is an access port? This guy right here is access. An access port is accessing what? A VLAN. So PC1 access VLAN yellow. PC2 access VLAN what? It's yellow, right? PC camera 1 access VLAN purple. So access port, access port, access port, trunk port. Why is this a trunk port? Because it's tagging. The keyword is tag. It's tagging the VLAN traffic, right? Remember that. Like this is more important than the actual implementation. When I go in there, everything you see here, I will do it in 5 minutes. When we go do the implementation, it's going to be in 5 minutes. The most important thing is that you understand this principle. So 2 things that you get from today. This is the industry standard right here. IEEE 802.1q. And what the switch, for every switch port that you see right there, they can either be an access port, meaning it's accessing a VLAN. The port is accessing a VLAN, right? Or a trunk port, it means that that particular port is tagging the VLAN traffic. With what? Tag with what? Industry standard. IEEE 802.1q. All right? So the exercise that we're going to have, like I was saying in the beginning, we're going to have this topology, internet. We're not going to do anything with the internet just right now. Firewall. We're not going to do nothing with the firewall just right now for today's exercise. And then we're going to connect to the switch. And then the switch will have 3 pieces. And each of those pieces will have what? Each of those pieces will have PC1, PC2, PC3. Each of those PC will have a VLAN, right? So this will be PC1 will be on VLAN 10. PC2 will be VLAN 20, and PC3 will be VLAN 30, right? And I will have subnet. For this subnet, I will have 192.168.10.0/24. I will have 192.168.20, right? That's 0/24. And then I will have 192.168.30.0/24, right? And I will do the VLAN routing right here. So my target is to make sure PC1 is talking to, PC2 is talking to, PC3, and is talking to, PC1 is talking to PC3. So all those PCs can talk together. Though they are in different VLANs, they can talk together. So meaning after configuring all of them, we're going to try to ping the PCs. What is ping? Ping is if we want to check connectivity between PC1 and PC2, we're going to send what we call a ICMP. That's the protocol, right, for ping. I'm giving a lot of information because you're going to have a week to cover all this and understand all this. I'm sending an ICMP echo and ICMP reply between the two. This is basically to test the connectivity, right? We're going to ping. Ping is sending, it's like I'm sending 4 packets, right? I'm sending the first packet, is going and is coming back. I'm sending the second packet, is going and is coming back. I'm sending the third packet, is going and coming back, and I'm sending the 4th packet, is going and coming back. Now, if every time it's go and come back, I'm calculating the latency. And then I say, okay, I have connectivity, but the connectivity is slow or the connectivity is fast, right? If it's slow, what is it that is making it slow? So it's a tool to test the connectivity, all right? So that's the exercise. So when we configure each PC in its broadcast domain, we're going to try to ping them and see if they respond. We're going to see that it's not working because they are in different broadcast domain. Now, we're going to use a layer 3 device, L3, meaning It could be like a router or a switch. For this one, it's going to be a switch. So this switch will be L3. So the L3 will basically use the routing, not just the MAC address forwarding, but the routing to forward those frames, right, at layer 3. So at layer 3 is not frames anymore, it's going to be packets. So that's that interconnections between layer 2 and layer 3. All right. So this is the part of the lab that I'm going to start with. I will add another PC. Let's say node. This is exactly what we were doing earlier. Those 3 PCs connect to one switch, right? This one will be VLAN 10, VLAN 20, VLAN 30. And then we're going to do the VLAN routing right here. All right. I will just turn on those 2 because we don't need the firewall today. Start. Now, one thing I want to show you guys is because we have all those sites, it's very important to the choice of IP address that we select, right? So this is how I will select my IP address. My IP address is, where is my whiteboard? So I will basically use the DC. Will have, so I have the DC here, I have my internet, I have site 1, site 2, and site 3. So here my DC will have 10. The second octet will be 0. The third octet will be 0. That's 0. No, I will have 1 right here. I will have 10.1. That's 0. That 0 /16. So this side one will be 10.2. This one will be 10.3. This one will be 10.4. All right. So, and everything else, like if I have VLAN 10, VLAN 10 will be 1, VLAN 20 will be 2, VLAN 30 will be 3, and so on and so forth. 1, 2, 3, and everything will be /24. 1, 2, 3. So, and the data center is going to also be one because we have more network at the data center, 2, 3, 4, 5, 6. But the distinction is you look at the second octet, it's giving you the site ID for the site, right? The second octet will make the difference to know which site are we on. So for this one, we're going to use 10.4, that VLAN 10.1, VLAN 20.2, VLAN 30.3. All right. And that's 0/24 for all of them. So that's how we're going to do our IP addressing. So with that said, this guy right here will be then that for that 1 that 0/24. So this is for this VLAN and the other 1, 2, 3. All right. So let's start configuring the switch. Let's start configuring the switch. I will open it right here. Okay. This first, what you see here is called user exec mode. You have the switch and then you have that sign. It's called user exec mode. User exec mode. All right. The next will be called privilege. Exec mode. And to go from this to this, you have to enter the command enable. All right. So Here we can pretty much see not see too much. If you want to see what you can see here, you just type question mark. Here you can say you can access enable, you can access profile, you can clear, you can connect, you can crypto, like you can say a lot of things, you can ping, you can all these things can be done. All right. But not so much, is very limited. If you want to see more, you go to privilege exec mode, meaning you have to enter the command enable. You see how it changed from this to this, right? So this is the privilege exec mode. And the next level is the configuration mode, where you're going to start entering configurations. And to get there, you have to enter configuration, configure terminal, config T, config T, conf T, config T, configure terminal. This is taking you to the next stage, which is the configuration mode. From the configuration mode, then you can start entering your comments. The first comment that you can enter is hostname. For example, if you want to give a name to the switch, you just type host, and then you enter the name of the switch. Is I will call it site for call underscore call. Right? And this is the name. You see how the name changed? Host, I call it site for underscore call. Now, in the naming convention is something that you have to take serious, because if I call this site for underscore call, the firewall will be what? Site for underscore firewall, right? Firewall 1 or firewall 2 if I have naming issue. So that's basically how we do the naming convention. But today, this is not really what we're here for. We want to make sure that we configure our switch port, right? Here we have PC1 that is connected to Ethernet 01, right? Let's configure that port. Interface Ethernet 01. Now I already selected this interface right here. Now, what is the configuration? Now I have to, before I do anything, I have to enter the description first, right? What is this port used for? Description is used for connected to PC1, right? Connected to PC1. The next command I want to say is switch port mode. I say how many type of switch port? 2, right? The first is access, the second is trunk. This one is an access port, switch port mode access. And then I will type switch port access VLAN. I will call that VLAN 10. Okay. Now it's saying VLAN 10 does not exist. It's creating VLAN 10. That's one way of creating VLAN 10. The other way is just type VLAN 10. It's going to create VLAN 10. And you can add the name. I will call VLAN 10 length. Data. I call VLAN 10 data, right? And yeah, we're going to do the same thing for VLAN 2, right? And let's configure the next one. Let me configure the VLAN 20. Next VLAN is you just type VLAN from right there, VLAN 20. That's the other way to configure it. VLAN 20 name. I will say printers. Printers. Then VLAN 30. I will call it name servers. Now interface VLAN, no, interface E0, so switch port mode access, switch port access VLAN. What? 20. Now look at this. Instead of writing all this, switchboard mode access, I can just do this, switchboard mode access, right? And I can say switchboard access VLAN 20. As long as you have the right syntax and you just enter, the switch understand all those, like, should I say abbreviations? It knows what you're trying to say. So I will just say 3, switchboard mode access, switchboard access VLAN, what? 30. Oh, yeah, let me add the description for port 30. Description is connect. Oh, you don't have to say too long. You just say this is what server, this, let's say server 10, or just server. Description server interface E0/2 in description what printer. So the reason why I put the descriptions, and if I say show interface status, look at this. It's very, very important to be like, okay, Internet 1 is connected to PC 1, right? Internet 2 is connected to the printer. Internet 2 is connected to the server. And that's his VLAN, right? 30, 20, this, right? And I can even add a description on this port. Internet 0, right here, is connected to the firewall, right? Let's do that. Config T, interface Ethernet 0/0, description, uplink. We call this uplink. Uplink to firewall 1. And show interface status. You see, this first port connects to firewall 1. This is connected to the PC. This is printer. This is server. And you have different VLANs, right? This we're going to take care of it after. We're not telling you that. Having said that, we can also check our VLAN configurations. Show VLAN. You can say show VLAN brief or show VLAN. It's the same. Now, this is what we did. We configure VLAN 10. We assign one port to it. We call it data. We configure VLAN 20. We assign one port to it. We call it what? Printer. We configure VLAN 30. We assign one port to it. We call it servers. And all those 3 that are here, 4, those are what they call default VLANs, including this one. They're reserved. Those VLANs are reserved for different purposes. Now, VLAN 1, all the switch ports are in VLAN 1 by default. All right? And it's also going to be considered as native VLAN. I will introduce native VLAN the next time. So, with that said, we already have part of our configuration set. Now, because we cannot do DHCP right now, we don't have a DHCP server, and I have not talked about DHCP yet. I will configure the IP address in those switch. Before doing that, I will configure the VLAN interface. Very, very, very important. For us to be able, let's go back to the whiteboard. I said something earlier that was very, very important, but I did not explain how it's going to work. For I have 3 different ports right here, and now I have a layer 3 device that is a router. So, and they're in different VLANs. I want us to be clear on that. So this is purple, this is yellow, and this is green. So each of those devices can only communicate with device from the same nature, right? If I want this PC1, PC2, PC3 to if I want PC1 to communicate with PC3, right? This traffic cannot go through because they're in different VLAN, right? Now, the only way it can work is each one of them can connect to his interface on the router, right? I have this, and I have yellow. Each one of them can talk to his own interface on the router, meaning yellow can talk to yellow at layer 2. Purple can talk to purple, and green can talk to green. Right? So what's going to happen here? The router is not looking at the MAC address of the devices anymore. The router is looking at the IP address because this is what we call routing table. So in the routing table, I will have 192.168.1.0/24, 192.168.2.0/24, 193.168.3.0/24. That's my routing table. And each of those have, this is by VLAN 1, this VLAN.
Can you check the last IP address?
VLAN 3, 192.168.3, right? This is VLAN 3. So basically, from the router perspective, the router is not dealing with VLAN. The router is dealing with subnet and routing table. When those guys send that traffic to the router look at the routing table and say, okay, this guy IP address I see is coming from this, and he wants to go here. Then the router can route. So they switch forward information based on what? MAC address. The router forward information based on what? IP address. The switch has a MAC address table. The router have what? A routing table or an IP table, right? So the router just needs to know what are the IP address, the subnets that are represented in my routing table. Any subnet that is not here cannot be reached, right? So that's the interaction between layer 2 and layer 3. Any communications at layer 2 between two VLAN at layer 2, they will need a layer 3 device. Now, there is a switch called L3 switch that has some routing functionalities, meaning that can act as a router. So that's the switch that we're using today. For this switch, we're not going to need to use this router to have our routing functionalities because it has a router integrated, right? It has a router inside right here. So that's what we're going to start doing. for our, we're going to create a virtual interface that we call what? What's the name of this virtual interface that we're going to create? A switch virtual interface, SVI, right? SVI. So that virtual interface will be like that interface that I just showed you on the router, that had the color on the router. And then we're going to assign an IP address to it. And as we are assigning an IP address to that virtual interface, and then we're going to enable layer 3 connectivity, it's going to give us a routing table. And as soon as we have that routing table, we will be able to have that inter-VLAN routing configured. That's okay. That's okay. You can ask your question. Okay, you on mute if you're talking. Anyway, we're gonna keep going. With that said, let's go back to our lab. We almost finished. So we're gonna say interface VLAN that, right? Oops. Okay, we have to go on configuration mode. Config interface VLAN 10 IP at now there's a command that we need to add before entering the IP. Switch port and encapsulation. Switch port trunk. No. Oh, can I just enter IP address? Okay, hold on. IP address. Okay. Yeah, I cannot put it in switch one more time. Okay, but I can add an IP address. IP address 10.4.1. That one, is it 1? That's 0. No, that 1. 255.255.255. That's 0. Okay. Interface. Oh, and I have to say no shot. No shot. Because it's a routed interface, I always have to say no shot. So I will just do the same thing. Interface VLAN 20. IP address. That's so that one. No shot. Interface VLAN 30. IP address that 3. That one. No shot. Okay. Now the last command that I need to enter is what? IP routing. This is the command that is making. Now look at this before I enter the command. And show IP route. Okay. Apparently it's already configured. Is configured by it's by default a layer 3 device anyway. But usually you have to enable the command IP routing, right? So look at this. Look at my routing, my IP routing. I would not just have connected. Show IP route connected. Okay, look at this. It's showing me, this is my routing table, right? It's showing me that I have this device that I'm learning this subnet from VLAN 10, right? And I have this IP address for the actual VLAN interface VLAN 10. I'm learning this other subnet from VLAN 20. I'm learning this other subnet from. So as far as this switch is concerned, it's a layer 3 device, and it knows how to send the traffic, the layer 3 traffic, to each of those pieces, right? Not layer 2, because layer 2 is only the VLAN, is the MAC address forwarding, but layer 3 is IP address. So it's only now, after doing this exercise, that my pieces can communicate together. But they can't quite communicate together right now because they don't even have an IP address yet, right? Now, those Linux pieces, you have to enter, you have to say, I don't know what is IP, no, you just enter the IP address, 10.1.10 subnet mask 255.255.255.0 and default gateway 10.4.1.1. Bad comment. Okay, you have to say IP. IP. Okay. So that's how you give IP address right here. You say IP, you put the IP address, the subnet mask, and the default gateway, right? Now, I told you in this class that, and this is the interface that we created in the switch that is going to talk to, right? That this PC can talk to in the switch, right? Is the virtual interface. Remember this diagram. Each of those PCs will be able to talk to their virtual interface. I will have those virtual interface that will be created right here. One is right here. The other one inside the switch. The other one is right there. And the third one is right here. You see this? So each of those pieces can talk to their default gateway. The yellow can talk to its default gateway. And the green can talk to its default gateway. And from here, they can do the routing. They can route the traffic to each one of them. So that's basically what we did here. So from the same subnet, this is 10, and this one will be, the default gateway will be that one. That's it right here. Every time you give an IP address to a device, is the IP, is a subnet mask, and the default gateway. Let's do the same thing for this one. Is IP 10.4.2.10 255.255.255.0 10.255 that what? No, 10.4.2.1. Okay, now the last one, but not the least. So IP 10.4.3.10 10.4.3.1. Okay, now that we have that, let's ping PC1. Ping PC1. The ping is 10.4.3. That one. 10.4.1.10. It's pinging, right? The first ping will always not work because the switch is learning those MAC address is the app process that will be going on. If you want to know about app, make some research. You have it in the other videos. Let's ping the other one. So that one, that thing. I'll process again, and then it ping. If I ping it again, the first ping will still work. Now the first ping work. Now the exercise is successful. Those pieces can ping each other, and the switch just made what we call the VLAN routing in the core switch. Right. The next exercise will be to use from here. We're going to do the same thing, but we're going to use the firewall to do the router on the stick, and the pieces will be able to pick up IP address with GSCP. So please don't miss the next video, and I will see you in the next video. So I hope it was very informative, and see you guys in the next video.